Hello, everyone, and welcome to the Ceylon Graphite Live Summit, hosted by Six. I am pleased to introduce their speakers for today, Sasha Jacob, the CEO, and Klaus Leiders, their Chief Mining Manager. Sasha will introduce Klaus and ask him questions, provide some company updates, and after that, we'll be accepting questions. As a reminder, you can submit your questions in the chat at any point during the presentation. As always, this summit is being recorded and will be available to watch live on Six.com or watch the recording of on Six.com. So without further ado, I'd like to hand things over to you, Sasha, so that we can get started.
Great. Thank you, Maxim. Good afternoon, everyone. Thank you for joining. Thrilled to have this opportunity to introduce you to our new Chief Mining Manager, Klaus Leiders. Klaus and I had the opportunity to meet a few years ago in Sri Lanka. And Klaus is one of the very few experts globally in vein graphite and has operated and expanded, significantly expanded a mine in Sri Lanka prior to joining us. So we're really thrilled to have him to join Ceylon Graphite, and we have some great plans we can share with you, and you can hear directly from Klaus about the operating conditions in Sri Lanka, about the geology, about our mine specifically, and our team specifically, which he's overseeing now, the team on the ground. So with that, Klaus, thank you for joining us and doing this and speaking to the investment community.
Thanks, Sasha. Should I introduce myself briefly? So
yeah, please. Maybe we can.
Okay.
That'd be great, and then maybe a bit of your mining background outside of Sri Lanka first would be great to hear about that.
Well, I've been in the business for over 40 years now as a mining engineer, and especially from the operational side. Managed large operations up to 2 million tons per day, down to just a few thousand tons per day. Went from commodities from coal, as you may guess, gold, talc, industrial metals like lead, zinc. Now I'm currently also involved in vanadium and for the vanadium redox flow batteries. But mostly the recent years, I've been focusing on graphite. Graphite, no matter what technology or batteries EVs are using or electrical storage are using, is the key element that you always have to build in. So I guess that everybody is mostly interested in my graphite expertise. I came to Sri Lanka the first time in 2016. Took over the Ragadara mine, which at that time was a mine that was producing between 20 and maximum 50 tons per month. The plant that was sitting there was a test plant, and my task was to bring Ragadara to 300 tons per month and modify the plant so that it could work as a continuous processing plant and produce also at least 300 tons per month. The team at Ragadara and myself, we managed to do so in just 8 months. And then we proved that also with the technology we had specifically developed for the Sri Lankan graphite, you can reach up to 99% without special technologies. Everybody else so far is happy when they reach 95 to 97% total graphite contained. And at Ragadara, we did it 99% by just employing known and working technologies. So I did a second stint in Sri Lanka after a brief interruption, where we did exploration on over 120 square kilometers, and that gave me in-depth knowledge of the Sri Lankan geology, which is quite amazing when you look at that. Sri Lanka is an island, yes, but it's also a continent by itself. It's a piece of the old Gondwana continent that was dragged behind the Indian continent when the Indian continent hit Asia. So if you come over to Sri Lanka, you will see a rock that is a few billion years old. Not millions, no, billion years old, exposed at the surface. And this rock has unique features. From that geological event when India was hit by Sri Lanka, you have west to east cracks through the entire island. And the amazing part is most of those cracks are filled with graphite, because the graphite event a few 100 million years later was that you had liquid graphite coming from the from the crust of the earth, pouring into those cracks. And with that knowledge that we could acquire with our exploration works, I talked with that to Sasha, and that's how we all started, because we say here, Ceylon Graphite has a lot of potential to be developed in a industrial volume producer of graphite.
Actually, that brings me to, I guess, one of the questions we get quite often, which is about the resource. And, of course, everybody looks at the 43-101 and the size and the tonnage. And this is a very different system, of course, as a vein system than most other mines. So maybe you could speak a little bit about that resource as you're just beginning to, because of the unique geologic condition, and how that resource is expanded, and based on your history and direct experience, what you expect to see as we're continuing to go deeper with M1 and other mines.
Yes. Now, first on the exploration part of the graphite, generally speaking, in Sri Lanka, to find veins with vertical holes in core drilling is not that easy. It's more like looking for the needle in the haystack. But once you have done the right prospection, meaning that you go on the surface, whether it is through the rice paddies or through the jungles, that's where you find the vein systems. When you know that almost all, about 90% of the veins in Sri Lanka are going vertical along strike, in dip, and the strike is always west to east. Then you know that you only have to follow those veins vertically with the shaft or anything. The veins here in Sri Lanka do pinch and swell like every other vein system, like, for instance, from the gold industry or other vein minerals. But they have one unique feature. When you, for instance, find about 10, 12 veins on top, on the surface, these veins may be between 5 millimeters and maximum 20 centimeters thick. But as you go down deeper into the deposit, they join. And rules of thumb that we have developed in those years of exploration is that for every 10 meter, you gain between 5 and 10 centimeter in thickness, because as the individual veins merge, they also gain in thickness individually. You can still follow those individual veins further down. The material is separated by not by host rock material or something like this, but by different types of crystallizations, because these veins also have crystallized at different times in the geological times. So as you go down deeper, the very same veins that gave you a total of maybe 40 centimeters at surface will give you 2-3 meters of thickness, 300 meters down. Yeah, the most known and famous examples. Sorry, I spoke French all day. My English is having a little trouble today. as the most famous example is the Bogala mine, which has been mined for 156 years, if I'm not mistaken, owned by a German company, Kopfmühl. As they go down, they found that their veins are getting thicker and thicker. They're now mining a 2.5 meter thick vein, and they do have 3 more on the same licenses that are even thicker, which they consider their reserves for the next years to come. You can go to Kahategaha, the state-owned mine, and it is exactly the same thing. Kahategaha, if I'm not mistaken, is now at 320 meter mining and about 700 meter development. And they do have the same events. The very thin veins from the top all have turned to thick, mineable veins through merging, and then this normal swelling as you go deeper down. I had spoken with geologists who are very familiar with the Sri Lankan geology, and all of them were telling me that they anticipate that as you go down, you might hit a maximum thickness of 5 meters, which would be spectacular. Well, going that down means 1,000 meters down. In other words, all the reserves of any Sri Lankan graphite projects are very deep down, but it is worth it because as you go deep down, the material gets richer and it gets more pure. Try to imagine when you have a 10 centimeter vein coming up at 3,400 degrees, dissolving the contact zone with the host rock. That brings in pyrite, that brings in silica into the contact area of the graphite with the host rock. Now, that can be 20% of the total vein thickness as you experience on top. But as you go down, you have thicknesses of 50, 60, 80 centimeter and thicker. The relative loss of material due to impurities, pyrite and silica, are lesser and lesser and lesser. This is one thing why we at Ceylon Graphite are also thinking of employing a technology to mine the graphite so that we don't have to dilute our graphite with the contact zone material. Yeah, but back to the matter, to the geology. There are so many exploration projects in the area from where Ceylon Graphite is all the way to the east, to the main mountain ridge where you can find the graphite, and then south all the way to Colombo. And all of them have the same features. Amazingly, I've done some very complex geological projects in my life. It's absolutely uniform. You have, like at the Ragadara mine, you have veins 20, 40 centimeter thick. They go down, all of a sudden, they're only 1 centimeter thick. You dig 5 meter deeper, and they're back to 30 centimeter thick. So when you have found a system of graphite veins in Sri Lanka, it is almost 100% certainty that you can turn that into a mineable property, into a mineable deposit. It's just a matter how we develop it.
So that's, I guess, brings us to the next most common question that we get outside the resource, and that's the scaling of production. We get that not just from investors, we get that from customers and OEMs and others. And you've, of course, prepared a fantastic, very detailed mining plan based on all of your experience and based on everything that you've seen at M1 and the prolific nature of what appears to be a very prolific deposit with all the the veins at that property. Maybe you could talk a little bit about that, about the mining plans there, how it's going to expand, and how we're going to scale production over quite a relatively tight timeline.
Yes. There are two major prejudices about Sri Lankan graphite. The first of which is it's crystalline graphite, and you can't make battery flakes out of it. Totally wrong, because with the graphite from Sri Lanka, you actually can produce it in a form when you run it through the plant that you can predetermine what graphite flake size you actually want to produce. We have proven that at Ragadara mine always works with no matter what graphite from Sri Lanka. Now the second thing is, the second prejudice, and I had that from some heavy buyers of graphite saying, oh, Sri Lanka cannot produce large volumes of graphite. You will never produce 1,000 tons a month on a steady basis. Now, you probably noticed that I said prejudice, because that's what it is. As I had initially said, graphite mining in Sri Lanka is going down deep as quickly as you can go by technology. Now we have go through the hardest rock on Earth. In the crystalline rock is definitely the hardest one I had to mine in my world. So sinking shaft and building tunnels is a tough task, but it can be done. My plan to get us into 1,000 tons, and everybody in our team, including Sasha, who is not the mining engineer, but he's got quite some good knowledge about it, is that we develop our M1 down deep to at least 300 meters as fast as we can. We do know that we have mineable reserves from where we are now. We call it the zero level, which is the top of the range where we started with the shaft. And then going down 300 meters from that, we do know that we have mineable reserves in between. And how we get to them is relatively simple. We have about 550, 600 meters along strike under contract where we can do whatever we need to do for mining. Now the shaft is 50 meters off the eastern end, and we will start a decline tunnel, or decline shaft, some people say, at the western end of it, right along the boundary line, with about 20-degree angle, so that we can install conveyor belts later in order to improve the volumes that we have to take out of the mines, mainly to improve the volume, the transportation volumes for the tunnel rock, the waste rock that needs to get out, to improve the mucking times, and so on and so on. Now, once we reach a predetermined depth, which from the decline on is about 200 meters in total from the ridge, we are going to run a connection tunnel over to the shaft for ventilation purposes, also for the purpose of setting out exploration chambers so that our own exploration drill can drill horizontally in a star-like fashion in order to intersect all the veins that we have. And once this exploration is done, then we will mine from there. That means we have to make cross cuts from the main tunnel. We also will run cross cuts higher up. Once we have the knowledge where the veins are, we run cross cuts from there so that we have two directions. From the main tunnel, we will develop the mine upward all the way until we're at basically the shaft mouth, but also downward from the decline, so that we are never stuck with one development direction only. And that is pretty much the secret, so we can bring this operation in steps to 100 tons a month, 300 tons a month, 500 months, and so on, with the final goal, once we are at about 300 meter depth, that we reach 1,000 tons per month. It's not rocket science, it's just calculating how many meters of tunnels we have to actually drill and blast per month to determine how many tons we can produce. It's very simple. If you want to produce 100 tons, you have to drive 30 meters of tunnel if you have 1 meter thick vein, just as an example. So we're going to do all that. And in the meantime, we're also looking at expanding the mineable reserves west to east by exploration drilling, then acquiring the necessary properties so that we can develop those properties also through the main entrances of the mine, which is that decline and the shaft. In the end, it will be that the shaft only will be there for personnel hoisting to the processing plant up from the mine site, where all the things like shower rooms and that are. And the decline will be the production tunnel through which alternately goes the waste rock and also the graphite itself.
Great, thank you. You've of course operated a pretty large, or managed a large team in Sri Lanka previously, and want to just get some of your thoughts about our team, both the geologists and the miners, and the plans for them and working with them at both sites.
Yes, thank you for mentioning that, because I had lost a lot of sight. Sri Lankan workers in general, especially in this area, are very hard workers, simply because they're used to the extreme hard work in the rice fields and on the farms or the coconut plantations. These guys don't mind to work really hard. I was very proud of being the boss of the Ragadara mine in their view, that they have a very traditional way of looking at the man that carries the responsibility for their work. And it's a very healthy relationship between the workforce and the one who carries the responsibility. I'm not talking about myself, I'm talking about general. And it was a very rewarding working relationship, because whatever had to be done, the workers did not mind. They didn't ask questions. It's just, okay, we do it, don't worry. When you come in the mine, it's done. And it was always like that. Now, the pool of workers who can work for Ceylon Graphite is rather vast, because there are only 2 more mines in the area who employ miners. But there are many, many more workers who have mining experience, namely those who has worked at Ragadara mine. Ragadara mine had been scaled down because after the joint venture fell apart, the workers were laid off. And now I'm sure if we call them up, at least 60, 70 well-skilled workers will apply to work for us, and which is exactly about the number that we need to develop the mine in the quickest fashion. Because what we are going to do is something that only is going to be done a second time in Sri Lanka, and that is working on a 4-shift regimen. As everybody may be aware, time is precious, and if you only by law are allowed to work 7 hours in the day, and you deduct 1 hour of breaks and another half an hour for going to work site for the miners, you only get 5.5 hours of work time. That was our experience at Ragadara. So what we did, we spoke with the representatives of our workers. They had a council, which is not something to do with unions, so nothing to worry about. It's a council. That means the workers have elected somebody who you can speak to, so you don't have to beg in different languages with each other. And we had spoken with them that we have the idea to only let them work 6 hours a day, but 24 hours a day. That means in 4 shifts, meaning the people come to work, go straight to site, speak with their colleagues, what has been done, what has to be done in their shift, and then the shift before goes home, and so on. Something that is pretty much common, mainly in underground coal mines around the world. I'm used to it all my coal mining lives, over 15 years. And it works. It makes the mine very productive and also safer, because in the heat that you have in these mines, especially also in Sri Lanka, people get very tired after about 5.5 hours. So it's good if they can leave after 6 and all is good. And it is something that can be done simply. The salaries for the individual worker are so low that you actually can give them 1 hour as a gift every day. It wouldn't hurt the financials of the company at all. You're looking at about $300 a month. And you still, with working instead of 7 hours, working 6 hours, you get a much higher performance. We had experienced in the tunneling, improvements in the tunneling between 20 and 30% per shift. In the graphite mining, it was much more. We had production improvements per shift in excess of 50%, because the people were motivated. They knew, okay, I'm coming, I speak 15 minutes now, and then I'll really work hard for the rest of the shift, eat on the go, and go home after 6 hours. It was a great motivation tool. And that's what we're going to plan for Ceylon Graphite also.
Great, thank you. We have a lot of good questions. I'm not sure if we'll have time to get all of them, but I'll try. I'm just going to try to combine 2 questions here into one. So one was, one of our investors has noticed we don't talk about K1 as much anymore. We've been prioritizing M1. So maybe we want to highlight why that reason is, and why we're moving so fast and pushing M1, and then what the plans are for K1 and how that's sequenced now.
Yes.
And also, that same question led to another question about how we're going to bring on additional sites and locations, and the plan for that. And in fact, your mining plan does very clearly outline an expected timeline for those additions, which we can say we've been actively working on. We have a pipeline of existing assets plus new assets, which we are prioritizing continuously as to which ones to bring into production. But maybe you could just highlight how you see that rolling out, maybe average tonnage, and how that all scales up into our goals of getting to,
Yes.
15, 20, 30 plus thousand tons.
Yes. On K1, I was in K1 personally a few months ago, and I was shown every corner, every vein, everything. It's a mine which has been extensively mined in the past 40, 50, 60, or even more years back. Now, it's quite unfortunate for K1. The previous operators ran into a pinching area. And as there is still vast potential that down dip, the mine will go back to normal, and the veins will have the thickness that has been experienced higher up. It did not have as much potential as M1. What we will have to do at K1, do some drilling, because we now know exactly the strike and also the dip of the veins. At K1, the dip is between 70 and 80 degrees. So intersecting them with drilling is more simple than it would be at M1, because that's where the veins are all vertical. And I found it is more simple to have access to the lower portions of the deposit at M1 for many reasons than it is at K1. if you want to have access at K1 to the lower portions, you have to go into the rice paddies. And that alone means we have to discuss with the rice paddy owners, find agreement, all doable, nothing out of the extraordinary, typical for Sri Lanka, and it's all something that can be done, but it will take time. And we want to go into production as quickly as we can. Now, the main ridge of M1 is in a small side valley with very little traffic and just a few neighbors, which, by the way, are pro-mining. They will not cause us any problem as long as we give their sons, which have no job, who have no jobs, give them a job, and I'll be delighted to do so because it will create the loyalty we want. Now, at M1, developing in down dip is because of its location, easy access by road to the decline, so that once we bring the graphite out, we just can load it straight into a truck and haul it to the processing plant. The potential that the mines stay steady in their thickness in there, because also in the valley we found veins of significant thickness. That all the factors had led to my opinion that it is better to halt the development of K1 for the moment and focus on M1 only, so that we get into production, get to cash flow, and also convince the customers that we can do it in large volumes. And then once we are at that point, the company will have substantial cash to also develop other properties, which includes K1, but also the newly acquired or in acquisition properties that Sasha was mentioning. It will be essential to sustain a high level of production that we have anywhere between 3 or 5 mines operating at all times, so that we don't deplete the deposit that we actually running, that we don't deplete it too quickly or getting under too much pressure to develop and advance it, because some veins are getting mined out and we don't have replacement vein to sustain the production levels. Yeah. So that for that reason we have to plan not only M1 but also other ones, and we will see once we have access to these other deposits, which ones are the easiest to develop, and also the ones that show on surface the thickest veins, because that alone is already a clue how the vein system will develop down dip.
We're over our time, but there's a couple more questions.
Okay.
For those who aren't able to answer, please do email me at info@ceylongraphite.com, and happy to answer the ones that are still there. But Maxim, maybe actually just one more quick question, Klaus. I wanted to share. I mean, you've done something amazing, which is build a processing plant itself to process up to 99%. And there was a question that asked about, what are plans for processing. So our bigger plans are, of course, to do a large battery grade upgrader, which will be close to whoever the OEM partner is. But maybe we want to talk about that interim step just very briefly as we wrap up about our ability to process to 99 at very low cost, and to be able to do that with that value add at site in Sri Lanka.
Yes. As brief as it is possible, the purity of the graphite starts with the mining. As I mentioned before, we will avoid to mine the contact zone graphite. This is a material that we will store differently in a separate stack and then treat it also separately. If you do that, you already have run of mine at least 95 to 97% purity without having run it through the process plant. The second step is using a technique that everybody in the industry will tell you, no, it doesn't work. But we have proven it does. The 5% impurities of Sri Lankan graphite is about 60% of silica and about 40% of pyrite on average. It varies, but that's pretty much the average. So when you run the crushed graphite over spirals, the free silica separates very clearly from the graphite, although the specific graphite is not very far apart. It's only 0.4 gram per cubic centimeter. And honestly, I myself was very concerned it would not work. But our young engineers at Ragadara took me to the University of Moratua, and we did a half-ton test on their spiral systems, and the outcome was spectacular. Just doing that got us to 98%. Just running over some very simple technology. Then the next thing we did is we floated the graphite, but not with the conventional box-type flotation boxes with the trailing arms and all that mechanical stuff that costs a lot of money to operate. No, we used a Canadian technology that sometimes is already forgotten. We used flotation columns, which by diameter and length were specifically designed for graphite. And that got us to 99%. That's where we said, okay, 99% is a steady quality we can deliver with just that. The rest of 1% is then about 60 to 65% pyrite and 40 to 35% silica, and you cannot get it so easily out. These crystals of silica and pyrite are intergrown with the flakes, and they have not been liberated through the crushing process. Now, you can try to mill it out. We tried that also in a laboratory test, but then the outcome is that your flakes are too fine to become a sellable product. Yeah, they're nice. You get to 99.9 actually that way, but the flake size is not attractive for your customers. And we are currently speaking with a provider of a new technology that has proven that you can liberate those 1% and make a 99.99% graphite. And we're currently debating if we should exfoliate the graphite prior to that technology step, or what is the best sequence of process steps. It takes a lot of more testing, meaning we probably have to produce about 10 tons and then bring that all to the laboratory and try the technology out with that we have in mind. If it is so, then we will have a rather sensational effect, and that is we don't have to heat up the graphite to get the pyrite out. It will mean that we can get the pyrite and the rest of all other impurities out to even meet the 20 ppm threshold of impurities that EV battery makers and also the cell phone battery makers are demanding nowadays. That's what we're working on. So we're doing not only conventional mining in a relatively rustic but effective process already, but we're also looking to find the most energy effective process to make battery grade graphite.
Wonderful. Thank you so much, Klaus. Maxim?
You're welcome.
Back to you.
Awesome. Thank you. Yeah, so those are some of the questions that we didn't have a chance to answer today. That would be for PJ Harris, Brian T, a few more for PJ Harris.
Anybody is invited to approach Sasha or me through Sasha or whatever is most practical.
Yeah.
For any question, I'll be happy to answer those.
Yeah, so we'll email you all after the event and communicate with you there. And anyone else who hasn't had their questions answered, feel free to reach out as well.
I'll be happy to answer.
Yeah, so that's all for the time that we have for today. So thank you both for taking us through the updates and the Q&A. I want to thank everyone who submitted questions. So today's recording will be available to watch on demand in the coming days. So feel free to look out for that. And you can find more information on Ceylon Graphite by going to the website. So before we wrap up, I'd like to pass things back over to you, Sasha, for any closing remarks you'd like to make.
Great, thank you. I'm glad that everybody had the chance to hear directly from Klaus, really a global world-leading expert specifically in graphite, and as just concluded, we are doing much more than just mining, as you know from our technical team in London as well, which has been working very closely with Klaus to determine the path forward for those high value-added products and ultimately for the battery-grade graphite. Thank you, everyone, for listening, and again, if there's any other questions, please don't hesitate to email us. Thank you.
Thanks again, everyone, for participating, and I hope you all have a great day.